So imagine you have either recorded your own EEG data or you have downloaded data from someone else. Then of course you can start thinking like, how are we going to analyze this? Important for that is like what software to use, what type of computer to use, and how to organize and archive your data in script. So what I'm not going to do is I'm going to focus very much on the right corner of the schematic. The EEG acquisition software usually comes with the EEG system, so you don't have much choice in that. You just use it. Some EEG systems have generic software, some of them support LSL. LSL is one of these generic libraries. So if the EEG system supports LSL, you can use LSL software. But most of the time it's just like whatever software comes with it. Acquisition software writes the data and the triggers and the important markers to its own file format. That's also something that you can't really choose. And after acquisition, you may want to format the data or to convert the data from the original format into a more open format. And this is especially relevant for clinical EEG. Clinical EEG systems are not very open. They often have file formats that are very difficult to read because the clinical companies are not sharing details in the file format. So features can be some of the clinical formats, but not all of them. So that is important on the clinical EEG system that you already use the capabilities of exporting the data into another format, so that you have the original formats that you can read with the clinical software, but that you also have, for example, the PDF format, the European data format, which is a very widely used EEG file format that a lot of clinical systems also support, and then you export it into two formats. And then the PDF can be used for the analysis using other software. Another format that we already encountered is the brain vision file format. So that is also used by brain vision analyzer. So that's why it's often abbreviated as the BVA format. And it consists of 3 files. So this is one file with the extension PDF. This is 3 files with the header and the marker of the EEG. And ideally, what you want to do is after acquisition that you convert the data to the bits structure. Which means you can use this format or the PDF format, but that's also add metadata. EEG analysis software sometimes comes with the EEG system, but the software that comes with the EEG system is usually not that flexible. So you have software for clinical evaluation, mainly for epilepsy, for sleep, but that is more for reading the EEG. And that really has been designed, optimized for reading the EEG. So you can page to the EEG, as in the old days people would page to the paper written EEG records. But it's not really very flexible in terms of answering research questions. There is commercial software for analyzing EEG data. Brain Vision Analyzer is one of these packages. It comes with, so we use that at the Willis as well. It's really an additional license that you have to buy it. I'm not sure how expensive it is. And there's more specialized software such as DESA and Curry, which are 2 packages which are more for source localization. DESA and Curry both used also in epilepsy. For epilepsy diagnostics, if you want to localize where epileptic activity is coming from, but also used a lot for research. But most researchers are using academic open source software. YouTube is an example as well of multiple others. So for EEG research, most of the packages that are being used are MATLAB based. So that's also why this afternoon we're going to use MATLAB. Future is the toolbox that we've been developing for the last 20 years. It's a very wide used toolbox, it's very widely cited, and you can do a lot of different things. EEG Lab is also very widely used. EEG Lab is more focused on EEG, Future is slightly more general purpose. I am more familiar with Future than with EEG Lab, so that's why I'm using Future for the teaching area. The advantage of EEG Lab over Future is that EEG Lab has a graphical user interface. So in EEG Lab you can do your analysis without writing code and without writing scripts. But this means we do want you to learn a little bit of coding. So we don't want you to learn how to click. If you want to click, I can definitely recommend Brainstorm. Brainstorm is very good software, has has a lot of fancy methods. It has a very good graphical interface. The graphical interface of EEG lab is a little bit rudimentary. It works. It's not nice. The graphical interface of brainstorm is really nice. SPM, also worth mentioning, SPM is primarily software used for fMRI and MRI research, but you can also use SPM for EEG and MRI research. And I should add that with these 4 packages, I know all the developers, we know each other, and we work together a lot. So we share code, we share ideas, we just use a different strategy, we find different things important. All of these packages are developed by researchers for their own reasons, we share it. There's also Python-based software, and there's one very dominant package. So there's many very small Python packages. And Python, that is really the package for EEG and MRI analysis in Python. Also has elaborate documentation, things I'm not that familiar with. I've been working with Fusion for 20 years, so if you ask me to do an analysis with MRI Python, I would have to read the documentation just as you would have to read the documentation. MRI Python is really good, so if you prefer Python, I would recommend MRI Python. As I said, the rates on SPM, they have a graphical interface. But an important difference here is that the MATLAB-based packages, they're open source, and MATLAB itself is not open source. So MATLAB is licensed software, you have to pay for the license. So this week we can use like an educational license, so you don't have to pay. So that is a limitation if you do not have MATLAB. Python, of course, can always be used. MATLAB-based software they can also largely be used, but not completely to run with Python. That is what I suggested 2 weeks ago. But to be honest, I'm not checking whether how compatible feature is with Python. I don't have the time for that. I'm almost we have MATLAB, so I'm focused on MATLAB development. It might work with Python, it might not work. I don't have the time to check, so I'm not giving any guarantees. What is possibly relevant, so MATLAB also allows you to compile software. So I know that for using that based on an SPM, there are compiled versions. If you have a compiled version, you only use the graphical user interface. So you can't do scripting anymore, because that part is hidden. For future, you cannot really compile a compiled version because it doesn't have a graphical user interface. So those are just some considerations that you can handle. If you just think about the different packages, some are easy to learn, they have limited functionality, some are harder to learn and have more functionality. I would say that's the category of Future also. Future is a bit harder to learn, but it has a lot of functionality. Some are good for beginners, some are for advanced users. So at this moment you're a beginner, and we're here to help you to get to a more advanced level. So we're going to help you to show you how to write your analysis scripts. And you first have to learn some stuff, and as Mikkel was saying also with the Cyclify, the first steps seem to go very slow. Once you get the hang of it, you speed up really rapidly. Whereas if you start using a graphical software, the first step seems to go fast, but actually it's not very fast, and it's not going to get any faster either. Because you constantly have to click around. Whereas with scripting and with coding, you can make your analysis much faster. So MATLAB is a programming language of data analysis combined with syntax. It's very close to that of mathematics. Basic objects and matrix and has functional scripts. So this is what I like MATLAB for teaching. Because it really relates to how the math and how the methods are described in the matrix. The MATLAB code is very readable. Python code, personally, I don't find it very readable. With Python, you can write code that is readable. With MATLAB, it's much easier to write code that is readable. Because if it's about Python codes, well, you don't really care. But often you have to read your own code as well. You have to read your own code like half a year later. And then try to make sense of what you wrote half a year later. For me, that's an important thing, important consideration to use MATLAB rather than Python. And as I said, like some of the software packages, they have graphical user interfaces. Some of them actually use, like brainstorm uses the graphical interface as well. So you also go to analysis this way. It's able to set instructions. So we'll actually use the scripts for that. So that's more or less what I want to present on choices that you have with regards to analysis software. I think the most important is that you get familiar with it. So you might want to try out different analysis packages and pick the one that aligns with the way how your brain works. For some people, having a graphical representation helps a lot. For other people, scripting helps a lot. In the end, the more advanced you get, as I said in the previous lecture, you kind of get this programming mindset. Because that's really how data intensive, such as your times, your using EEG works. Once you have this programming mindset, then writing scripts is very natural. But it is something that you have to do often, that you have to do for a certain amount of time, often enough, before you learn this. And that's why we wait for it as well. So it's learning how to write your analysis. Any questions?